So here's our second part of this lesson today. We're going to be looking at a certain inequality and how we go through multiple steps. It's called a multi-step inequality. You're probably familiar with multi-step equations. That phrase is pretty familiar to us. And what we're going to do is we're going to follow the same steps that we took way back in chapters 3 and 4 for multi-step equations in order to solve multi-step inequalities today. In order to solve multi-step inequalities, we have to make sure that we have simplified both sides of the inequality. So now that you have this glued into your notes, we're going to go ahead and work through a sample problem. The example is 2 parentheses x minus 2 close parentheses minus 1 is greater than positive 3. So that's our inequality that we're going to work through as we go through each of these steps to make sure that we have correctly done each of the steps. So by simplify both sides of the inequality, this could mean using the distributive property. Okay? This could also mean combining like terms that are on the same side. Say we had something like x plus 2x. We would need to combine those before we can do anything else with them. This could additionally mean that we need to simplify any double negative symbols. Let's say we had subtracting a negative 1 over here. We would need to take care of that and change that negative negative into a positive. So let's see, are there any steps in here that we would need to do for our problem? Yes, there are. We absolutely need to use the distributive property. We're going to take that 2 that's on the outside of those parentheses up there, and we're going to distribute it, multiply it out to the x and the negative 2. So we end up with 2x minus 4 minus 1 is greater than positive 3. Alrighty. Sometimes we might have to do all 3 of these. Sometimes we might just be restricted to one of them, like we were in this case. Next step. Use the inverse operation to add or subtract any terms in order to combine like terms on opposite sides. Okay. Let's see. Well, I think that actually before I even do that, I should really actually go back and combine my like terms on the same side. Sorry about that. But yeah, I really definitely need to do that negative 4 minus 1 on the same side before I go into this inverse operation that's moving stuff to the opposite side. So I end up with 2x minus 5 is greater than positive 3. Moving on from that, I'll definitely do my inverse operation to add or subtract. That's the key thing here, add or subtract. We don't want to go into any multiplying or dividing steps quite yet. We want to make sure that we deal with the positive or negative constants first. In this case, I'm going to add 5 to both sides to move that negative 5 over there, over to the right-hand side. If you visualize your equation mat, it would be like adding 5 unit tiles to one side and then adding 5 unit tiles to the other side. Again, in order to equalize them, to combine like terms. So we're left with 2x is greater than 8. Use the inverse operations, this is step 3 or task 3. Use the inverse operation to multiply by the reciprocal. That's if you have a fraction, you would want to multiply by the reciprocal. If you had, instead of let's say 2x, you had 1/2 x or 2/3 x. We would need to multiply by the reciprocal. Most folks forget to multiply by the reciprocal and they end up not getting completely correct answers. Now, if we have an integer, like we have here, the number 2, we want to divide to make the coefficient equal to 1. Now, here's the tricky part though. If we're multiplying by a positive value, which we are in this case, ours is a positive 2. If we're multiplying or dividing, doesn't matter which, by a positive value, maintain the same direction of the inequality. So in our case, our inequality is going to keep opening up to the left, being a greater than symbol. Whereas if we had been multiplying or dividing, again, doesn't matter, by a negative value, we would need to flip the direction of the symbol. Instead of opening up this way, like that, it would need to open up that way instead. Again, ours is positive, so we're not going to flip. But if it was a negative, we would definitely have to flip it. Like we saw in that one practice problem back on number 44. And then we're going to graph the inequality. But let's go ahead and finish this problem first. Again, we're going to divide by a positive. Because we're dividing by a positive, we do not flip the symbol. And we get our final solution of x is greater than positive 4. Our second step, or I guess our second overall step, we found our solution. Now we need to graph the final inequality on a number line. So we draw our number line. It gets arrows in both directions when we first draw it. But it won't get arrows in both directions when we actually go to plot our inequality onto it. Let's see. We have the number 4, so we always start at 0. 1, 2, 3, 4. Draw our circle there at the 4, and then ask ourselves, is it open or closed? Filled in or empty? In this case, it's going to be empty because there's no equal sign to fill in the value. Then we ask, are we going up or are we going down? Well, in this case, we say x is greater than, or the alligator is eating the x, so x is greater than the 4. And therefore, we should be coloring it in above, shading it in the direction it's traveling. Make sure that your arrow is super obvious as to which direction. If you look and compare my two arrows, it's incredibly obvious which direction my inequality is heading. Now there is another section, there's a third part to this problem as well, and that's what's called test points. What we do for test points is we choose a number that should be a part of the solution, aka where it's all colored in, and we choose a number where it's not colored in to prove and disprove. So in this case, I would choose the test point probably of the number 5. X equals 5 should be a solution. You guys, there is infinitely many solutions to this problem. It could be 5, it could be 5.5, it could be 5.125, it could be a myriad options here. But what we want to do is we want to choose one that's for sure part of the dark colored in section, where it should be a solution. And we want to choose a number that should not be a solution. The easiest number to choose would be a 0. X equals 0 should not be part of the solution, should not be a possible solution. So again, I'm going to set myself up for success by jotting that down to myself. That these two numbers, this one obviously should be because it's in the colored in section, and this one should not be because it's in the empty section. So what I'm going to go ahead and do is I'm going to plug in this value and this value in two separate forms back into the original equation. And hopefully, fingers crossed, it works. So our original equation again from up above was 2 parentheses x minus 2 close parentheses minus 1 greater than 3. So again, for this one I'm going to plug in a 5. I've got 2 parentheses 5 minus 2 close parentheses minus 1 greater than 3. I'm going to do PEMDAS here. 5 minus 2 gets me 3. So I've got 2 times 3 minus 1 is greater than 3. 2 times 3, multiplying step, 2 times 3 is 6. 6 minus 1 greater than 3. 5 greater than 3. That is a true and valid statement. 5 is bigger than 3, which is why this is a part of the solution. X equals 0 should not be a possible solution. Okay, let's plug it in and see. When we solve this out, it should not end up being a true or valid statement. We got 2, parentheses 0 minus 2, close parentheses, minus 1, greater than 3. Again, we're going to start by doing what's inside your parentheses, 0 minus 2, which gets us a negative 2. Multiply step, 2 times negative 2 is negative 4, minus 1, greater than 3. Then we're just going to combine like terms using our adding and subtracting. Negative 4 minus 1 would get us negative 5. Negative 5 is not greater than positive 3, which means that this is an inaccurate expression. This is not a correct statement, which is why that is false. So essentially what we've done is we have proven to ourselves, using algebra, rather than using our graph, if in fact our graph is true, and our graph met the test. There should be an empty circle at the positive 4 going upward, because 5 is a solution and 0 is not. That's how we do these problems. If you stick to these notes and you read them very carefully and you do them very precisely, and you always do your 2 test points, you will be highly successful at these one-step inequalities.